teaching it, the teacher that was here before me always separated the 2 semesters of pre-calculus, and first semester was all more algebra related, and second semester was all trig. And so that's just the way I've always done it. Well, you kind of need to know your algebra to do the trig, so we really could have maybe got through this chapter instead of chapter 9, but then we would have had break, and then we would have come back and started with trig proofs, and that's never a good way to start January. So I like to just start fresh with what is trig and what is a radian. So they give you this little picture here. Basically what this represents is one little section of a circle. If you want to actually kind of draw a whole circle here, you could. My circle's not going to be so great here, but let's just pretend this is a nice circle. One radian is defined as if this arc, notice this is A, is the same length as the radius of the circle. That's what makes one radian. We're going to talk about how does that compare to the whole circle, how many radians are in a whole circle, and we're going to get to all that. But that's the definition of one radian. And we're going to use radians most of the time. Your calculator actually has a radian mode. Most of the time when you turn on your calculator, it's in degree mode. And how do you know that? Because it has a little D at the top or DEG at the top. But you can change it to radian mode, and that's an important thing that we'll get to eventually, of making sure your calculator's in the right mode. But radians is what we use most of the time, unless maybe it's a story problem. Okay? So let's kind of talk about this a little bit more. Alright, so let's compare this to what we know about circles. When we're talking about measuring stuff, it's always good to talk about it in terms of a circle. And we should know that the circumference of a circle, which is the distance around the circle, is 2 pi times the radius, or pi times diameter. If the radius equals 1, and we're going to talk about that a lot, of a radius of 1, we call that the unit circle because the radius is 1 unit long. Think about if you plug 1 in here for r. Then the circumference around a circle with a radius of 1 would just be 2 pi. The 1 would just go away. So this is kind of an important thing. To go around a circle once is 2 pi radians. And why is pi in there? Because we're talking about circles, and that's the only time you can get a true circle is if you throw the pi ratio in there. So what about half a revolution? Think about in terms of radians. If going all the way around the circle is 2 pi radians, how many radians would be in half of a circle? Or how could I figure out how many radians would be in half of a circle? How many radians are in a whole circle? The radian is a measure of angle, just like degrees. Right? Like how many, we can talk about this right now if we want. I was on the next slide. How many degrees are in a circle? 360 degrees. And so if you wanted to take half of it in terms of degrees, how would you figure out how many degrees are in half of a circle? You take 360 divided by 2, right? And you get 180. There's 180 degrees in half of a circle. And then we could divide that in half again. That would be a fourth of a circle. That'd be 90 degrees, right? And we're a lot more comfortable with degrees because we've used them for a long time. But we want to start thinking in terms of radians. But we could do the same thing. If I know 1 revolution is 2 pi radians, if I just want to get half of it, could I just multiply by a half here? Or divide by 2, cut it in half? What would half of 2 pi be? Just pi, right? Don't be thrown off by the pi there. Just divide the numbers there. So we could say in half of a circle is pi radians. You don't have to put radians next to this, because if it was degrees, how do we write degrees? How do you know it's in degrees? You have the little degree symbol, right? Like 45 degrees. If it doesn't have a degree symbol, then it's in radians, and so that's something that you need to get used to as well. So let's just practice a little bit more math here. What about a quarter of a revolution of a circle? Or 1/4 of a circle? What would I do to find that? Yeah, I'm going to take the whole circle, which is 2 pi, and I'm going to take 1/4 of it. So that means I'm going to multiply by 1/4. 2 times 1/4. Half, right? 2/4 is 1/2. You could write 1/2 pi. Usually we're just going to write this as pi over 2. If you write 1/2 pi, I'm not going to mark it wrong, but pi halves. It's just fractions. I think dealing with trig makes you get better with fractions than you've ever been in your life, because radians are usually put in fractions, and there's pi in there. Let's do one more. What about if I just wanted to go 1/6 of the way around the circle, and I want to know how many radians are in 1/6 of a circle? I'm going to take 2 pi times 1/6, which is basically just 2 over 6. And what does 2 over 6 reduce to? 1/3. So 1/3 pi is the same as just saying pi over 3. You don't have to put the 1. When we're dealing with radians, sometimes they're decimals. Think about if you work this out on your calculator. If you took pi divided by 2, it's just going to be a really long decimal because pi is irrational. But the really nice angles that we use are always going to be written like this, in terms of pi, in terms of fractions, and this is how we deal with radians. The big thing that you're going to do today is convert from degrees to radians to kind of practice that, which isn't so bad. It's just a little bit of algebra. See if I wrote this on here. Oh, yeah. We know one revolution of a circle, I just told you, is how many radians? 2 pi radians, and I'll write radians there even though you don't have to, just to kind of show you. And we should know that that's also the same as how many degrees in a circle? 360 degrees. So we could kind of set up a conversion here. Think about when you're converting from feet to inches, you know that there are 12 inches in 1 foot, right? So you could say that there's a ratio, you don't have to write this down, but there are 12 inches in 1 foot, and that's a conversion, right? I could do the same thing with this. Could I say that there are 2 pi radians and 360 degrees in 1 circle, like those are equivalent to each other? And could I reduce that? If a 2 and a 360 I could divide out, and that would just be the same as saying pi over 180, or there are pi radians in 180 degrees. This is going to kind of be our conversion factor, and this is where it comes from, because a circle is 2 pi radians or 360 degrees. And so I think your book just tells you straightforward. If you want to convert from radians to degrees, you have to multiply by 180 over pi radians. But if you're going the other way, if you're going to degrees to radians, the pi needs to be on the top. I don't ever really think about these as 2 separate rules. I always just know pi over 180 or 180 over pi, and I kind of go back to the whole chemistry days of your units have to cancel out, so if you need your degrees to cancel out, and we'll look at some examples here in a minute. But you need to know that conversion factor. You need to know that there are pi radians in 180 degrees. Or you could use 2 pi over 360 if you want. I just used the smaller factor there. You don't have to put radians. Because if there's no degree symbol, then it's assumed that it's radians. Because it depends on what you're doing, right? And we're going to look at an example in a minute. But let's say if I had 7 pi radians, and I wanted you to convert that to degrees, do you agree that you have to make sure that when you're converting, think about back when you were in chemistry, if this is radians, I need radians on the bottom. So I'd have to put pi down here and 180 on the top. So then those units would cancel out. If you're converting from degrees to radians, again, think about that. Let's just make up a degree here. If I had 75 degrees and I want to convert it, I know it's 180 in pi, but I got to match it up. Well, degrees are up here. I need degrees to cancel, so I need 180 degrees on the bottom, so that way that those degrees would cancel out. Does that make sense of why there's 2 different factors? So again, like I feel like I put this here because it was in the book, but I don't feel like you need to memorize which one do I use which time, because it's really easy to tell. You just match it up and say, what do I need to cancel out? And it's really easy with the pi's because you want your pi's to cancel out. Okay? All right, let's, I have one more little thing and then we'll do some, we're just converting right now. And this is the majority of your homework today, not all of it, but the majority of it is just practicing converting, kind of getting you used to what degrees equal what radians. Notice I put up here, these are your 2 options. You actually could look back at that rule I just gave you and know exactly which one you're going to use if you're going from degrees to radians. But just remember, just use your what you know in your brain. You need the degrees to cancel out. You want your answer to be in radians, so radians needs to be on top. And these are your conversion factors. And you're welcome to use your calculator to simplify it. But if I want to convert 120 degrees to radians, all I'm going to do is I'm going to multiply by either 180 over pi or pi over 180. And since I want the degrees to cancel, I'm going to multiply by pi over 180 degrees, because 1, that leaves me radians on top, which I want, and 2, it cancels out those degrees. And then all you got to do is simplify it, which you can just do on a calculator, or the zeros would cancel, and you'd get 12 over 18, which 6 goes into both of those. So would that be 2 pi over 3? You with me on where I'm getting those numbers from? And that's it. Like, that's your answer. You just got to know what to multiply by, make sure you put it in the right spot, and simplify correctly, which you can use a calculator. And 120 degrees is the same as 2 pi thirds. And we do this so much at the beginning because a lot of people can visualize 120 degrees a lot better than they can visual 2 pi thirds radians. But eventually we're only going to be in radians all the time, and so we want to start kind of thinking about what that means. Okay? So you do this one. Same idea, multiply, simplify, and let's make sure we get the right answer. Wait, Carter, that's the next slide. You're so smart. Wait, what's on next? And again, you're welcome to just use your fraction button on your calculator, but this one isn't so bad. You get, 2 over 18 would be 1/9, so that would be the same as pi 9. If you put 1/9, again, it's okay. This is just how the book's going to write it, so I'm going to write it like that. Anyone have a question on that? Again, we're going to do the other way. They're going to give you the radians, and you're going to go to degrees. The only difference is what you multiply by, you got to flip it over, because now you want your answer to be in degrees. And it's really nice with pi in there because it kind of tells you if you want your answer in degrees, you want the pi to cancel out, hopefully. But again, this would be 180 degrees over pi this time because the radians would cancel out crosswise. So the pi's are going to cancel out. Your answer is going to be in degrees. If for some reason the pi doesn't cancel out, like maybe they give you a weird radian, like one that doesn't work out so nicely, it's okay to give me a decimal answer. I think there might be one on your homework like that, and I'm sure we'll talk about it tomorrow. But most of the time, the pi's are going to cancel out, and then you, again, can use your calculator here. I think 6 goes in 180, 30 times? 7 times 30 would be 210 degrees. Really, really important you put that degree symbol, because when I'm grading something, if it doesn't have a degree symbol and it's in degrees, I don't know that, and I think it's in radians. So it's really important that you put the degree symbol there. So you do the next one. Then we'll move on to our last topic of the day. Is it 105, is that right? That was a little arithmetic in my head there. 105 degrees. That's not so bad, right? That's a good first day homework. The last thing is talking a little bit more about degrees and maybe going into a little bit more detail with degrees than we ever have before. So this is my last concept of the day. This is used in navigation a lot, latitude and longitude, when people are navigating in an airplane, or especially in ships. This is when this was used a lot, back when people were navigating in ships a lot more, but I really think it's still used with airplane pilots. Instead of just giving a degree or giving a decimal degree, you can actually be more specific when you're giving your answer. And we can break down, we know that one revolution of a circle is 360 degrees. What about if I went 1/360th of a revolution? How many degrees would that be? 1 degree. I kind of showed the answer there. Right? 1/360th of a revolution would just be 1 degree. Well, you can actually break 1 degree down more. And we can say in 1 degree there is 60 minutes. And now you got to get past the whole idea that we think of minutes in terms of clock. Minutes can also be in terms of measuring an angle and measuring direction, like latitude and longitude. And so we say in 1 degree there are 60 minutes, and the way we put the symbol on it is we kind of put a little, I don't know, kind of like a dash, apostrophe. And I'm going to write here, this is read as 60 minutes. And then you can break that down even more. And you can say in 1 minute, there are 60 seconds. And so it does kind of match up with how we tell time, but it's in terms of direction. So in 1 minute, there are 60 seconds, and we put 2 marks on it. And we say this is 60 seconds. And they always throw this in here with trig. Do we use this a lot? No, but it is thrown in there, and it's something that at least make you aware of it. If you see this latitude and longitude, if you look up specific latitude and longitude, it's always written like this, in degrees and then minutes and then seconds, because it lets people have a more accurate location. So I don't know why it's not as accurate with decimal, but it's not. So what we're going to do is do some conversions with this also. Start kind of simple here. And basically, it's kind of a good little practice with algebra and converting. But if I gave you 27.5 degrees, and they said write using degrees, minutes, and seconds. Anything that's a decimal, you can break down into a smaller unit. So the whole part is just going to stay the degrees. 27.5 degrees, when I'm doing this would just be the same as saying 27 degrees. The whole part, don't worry about converting it. We don't want to convert the whole part. We want to convert the decimal part. So then I'm going to break this part down. I'm going to kind of put a plus sign here to show you that I'm just breaking it down. 0.5 degrees, I want to change that into minutes and or seconds if necessary. Just like our unit conversion with radians and degrees, we can do a unit conversion here, just like feet and inches, just like time. If I wanted to convert days into seconds, we could do the little conversion there. And right here's my conversion. There is 1 degree in 60 minutes, or there are 60 minutes in 1 degree. It's all about lining it up. If I want to change this degree into minutes, I'm either going to multiply by 1 degree over 60 minutes, or I'm going to multiply by 60 minutes over 1 degree. How do I know which one to multiply by? I want it to cancel out, right? I want those degrees to cancel out. And maybe you can just think about it. Probably don't even need to convert it. If there are 60 minutes in 1 degree, how many minutes should there be in half a degree? 30, right? Does that make sense? But to show you the math here, I can show you. I can multiply by 60 minutes in 1 degree, because the degrees would cancel, and a half times 60 is 30 minutes. I'm just going to add this back to this, and I would get 27 degrees, 30 minutes is how you would write that. You don't have to put the plus sign in there. So 30 minutes is the same as half of a degree. Again, what I want you to start practicing, and maybe at least realize from this, is you only have to convert the part that's a fraction or a decimal. Like on this one, the 27 was the whole part, so I didn't need to convert that. It's staying at 27. This one is already written in terms of degrees and minutes, 125 degrees, 6.5 minutes, but there is still a fraction there, which means I could still break this down more. So if you see a fraction or a decimal, it means you could go more with it. The whole parts I don't have to change. So this would be 125 degrees. I don't need to worry about that. The 6 minutes, it's already 6 whole minutes. I don't need to change that. But I do have to convert the fraction or the decimal. And I wrote it as a fraction this time, but I still picked a pretty easy one, right? A half a minute is going to be how many seconds? Yeah, and again, we can use the conversion, and we'll do one in a minute that's not so easy to do in your head. But in 1 minute, there are 60 seconds, so it should make sense in half a minute that there should be 30. Again, how could I do that with the conversion factor? This is my conversion factor right here. I just got to line it up. So in 1 degree, there are 60 seconds. Sorry, in 1 minute, there are 60 seconds. And that would be 30 seconds. And that's your answer. Again, unless you're going to be someone that's dealing with directions a lot in terms of navigation, you probably wouldn't use this a lot. Maybe astronauts use this? I don't know. NASA people? It's definitely like sailors and pilots use this. Let's do one more, and I'm done. Go the other way. What's wrong? Oh, pirates. Pirates, they're sailors, you know. I bet pirates use it also. This is the last one. Pick one that wasn't going to be just perfect, like a half, so we could actually work some conversions out here. But now we're going the other way. They're giving you the degrees, minutes, seconds, 315 degrees, 48 minutes, and 3 seconds, and really it's just about doing the conversion here. I'm trying to put it back in degrees. Do I need to change the 315? No, it's already in degrees, right? But I do need to change both the minutes and the seconds back to decimals. And so when they give you this, your answer is going to be a decimal. So the 315 is just going to stay 315. I kind of put a plus sign in here, but just know you're going to add this all together at the end if you don't want to do that. I'm going to change 48 minutes back into degrees. How many minutes are in 1 degree? 60. And if I want the minutes to cancel out, are the minutes going to go on the bottom or are they going on the top? Because 60 minutes in 1 degree, I need those minutes to cancel out. And notice that we have degrees now. So when we do that, we're going to get the degrees back. I'm just going to keep going here, and I'll do the adding part later. What about 3 seconds? For me, I do this in 2 steps, just like I would if I was converting seconds to hours in terms of time. I'm going to go seconds to minutes, and then minutes to degrees, because those are my conversions that I know. Could you just tell me how many seconds are in 1 degree? Probably by doing a little bit of math. You could, but I'm just going to do the 2 conversions here, because that's what I think about. How many seconds are in 1 minute? 60. So just like over here, should I put my 60 seconds on the bottom and 1 minute on the top? And again, I always put my units on it just like I did in chemistry class, because I want to make sure that my units cancel out. If I do this multiplication, does this have me back to degrees? No, it has me in minutes. So I'm going to multiply also by exactly what I multiplied over here, because to change minutes back into degrees, I'm going to have to multiply by 1 degree over 60 minutes to get those to cancel out. And then I can just use my calculator and get some decimals here. Again, it's kind of just some practice of some algebra conversions, but they always throw this in with trig for some reason. 48 over 60 is 0.8, and 3 times 1 over 60, or I'll just put 3 divided by 60 divided by 60. Oh, did you get a really small number? Like 0.0008 or not? Did you get that? 3, 3, 3. This is a reason that navigators like degrees, minutes, and seconds more, because this is just going to keep going here. The nice thing for us is they tell us to round to the nearest hundredth, which means how many decimals? 2 decimals. So if I add all this up, am I even adding any of this into my answer? No, because I'm rounding it off to the nearest hundredth. So I think I would just get 315.80 degrees. You wouldn't even have to put the 0 on it. Because if I only go to the first 2 decimals, I don't even count that. Which is why degrees, minutes, and seconds is a more accurate thing. Again, some of this on your homework. It's not a huge part of this trig stuff, but it does show up every now and again. So I like to show it to you. And it'll probably be like 2 problems on your test about it. Okay? I do have an assignment sheet for you. Are doing only the first 3 sections of chapter 4 before we have a test, but we will spend a few days. Like we're going to spend 3 days on section 4.1. That's just on notes of it. But today you are just doing day 1, which is the first one of the assignment sheet, 2 through 24 even. And then tomorrow we'll talk about what questions you have.